In our lesson today, we're doing more inequalities. The difference is up to now, we have just had an X like you see down here at the bottom. We've only had an X in there and we've drawn it on the number line. Today, we're going to be looking at inequalities like this one up at the top that has a Y and an X in it. So those are going to be lines in the coordinate plane that we graph as inequalities. So the first one that we're going to do is y is greater than negative a half x plus 1. These are called linear inequalities because either they already are, or we could get them in the form for y's by itself, and the other side is mx plus b, and we know if it's equal, if it's an equation, not an inequality, that's the slope-intercept form of the line. But now we're changing the equal to a greater than or a less than. We know on the number line that we have had to show the difference if we had less than, greater than, or less than equal, greater than equal. On the number line, how did we show the endpoint if we did not have the equal bar, Wyatt? So an open circle. And what did we do if we had the equal bar? Ethan, what did we do when we did have the equal bar? We colored it in. But it doesn't really make sense to try to draw a line that's like that. So we're going to do something different when it's a line that means the same thing. So what we're going to do is we're going to do a solid line if we have the equal bar, just like we did the solid dot. And we're going to do a dashed line or dotted instead of the open circles. So we have to take a look at that. And first we might decide, does this one need a solid or a dotted line? Everybody. We don't have an equal bar, so we know we need a dotted line. So first thing I'm going to do is to graph it like I would if it were an equal sign, if it were just the line, but I'm going to use a dotted line instead. So I'm going to look at this. What's my y-intercept? Everybody, what is my slope? So negative a half, so I need to go to the 1 and start there. Negative a half, so down 1 and over 2. Up 1 and back 2. It's important that you graph these accurately, not just a quick sloppy line that isn't really even straight. Plot points all the way to the edges, then pull out your straight edge and draw in your dotted or your solid line. Click the right thing. There we go. So there is my dotted line. Now, when we were doing ones on the number line, if we had like x is greater than 5, we found 5, and then we had to decide, oh, are we shading to the right or to the left? Which side do we shade in on? We need to do the same thing now, but with the line. Which side of the line do we shade? The way we're going to do this is we're going to make our guess by looking at the inequality, and then we are going to do a test point every single time to make sure we picked the right side. So y's are the up and down coordinate, right? And if I say y is bigger than or equal, that means I need points with a y coordinate that is bigger than the line or up above the line. And if I have y is less than or equal to, that means the y coordinate of the point of all the points that I'm going to shade needs to be less than the line. So it's got to be down lower than the line. And that's how we're going to make our guess. So for this problem, y is greater than the line. Everybody point above or below. What's our guess? We're thinking above the line. For a test point, every single one of these inequalities, I need you to write it. Which point are you picking? And show the work on it. It is important that it is not on the line, even if it says greater than or equal or less than or equal. We're trying to figure out which side of the line. On the line is always going to be equal and make it true. So we need something not on the line. So we need to pick something above the line with easy coordinates. I can pick any of these points that are above the line. Different ones of you will pick different ones on problems. Think about what's going to be easy. Usually zeros and ones are easy. If you have a fraction, like I do right here, maybe I want to pick an x that's even to easily cancel that out, or maybe an x that's 0 to totally get rid of it. So how about 0, 2? Is that above the line? And let's see what happens there. Now I need to show the work. I'm going to put a 2 in for the y. I'm going to write down that I picked 0, 2. 2 for the y is greater than. And then I'm going to put a 0 in here where the x was. So 0 plus 1. Is 2 greater than 1? So my test point worked. So that means, yes, I want to shade everything above the line. Most of the time, what you're going to do for shading is just do some stripes or some zigzags. Now, not like this. You want to show that you're going to the edges. Also, not like this. Show that you're coloring all the way to the edges of the graph, which means and beyond in that direction. Does that make sense? Another thing I want to point out, because I do this a lot, I get in a hurry when I'm doing these, and I draw my solid line. Oops, it was supposed to be dotted. And I try to erase little spots along it, but it's kind of hard to tell if I really erased or not because my eraser's not real good. And I still want to get credit for it. I don't want to get it counted wrong. If you ever do that, or just if the way you drew it and the way the grid is, you think it's hard to see, simply write dotted and put an arrow going to that line to let me know you meant for that one to be dotted or you caught your own mistake. I don't want to see a solid line and then dots along it, because I'm going to think those were the points you came up with just as you were figuring out, counting with the slope, rise and run, where to put your dots to line up your ruler. So either clearly dotted or label it with the word. Good with that? All right, now let's move on to ones that have two inequalities. So we're going to graph them one at a time, solid or dotted, and then we're going to figure out what part of the graph we need to shade. So everybody, top one, solid or dotted? What about bottom one? So both of them solid because we have the equal bars. So for the top one, Allie, what's my y-intercept? So I'm going to start at -2. And Leo, what's my slope on the top one? So -1, and so we plot that as -1 over 1, so up and down 1 and over 1, or up and down 2 and over 2 reduces to -1. If I don't want to do quite as many dots when the slope's 1 or -1. And get those all the way to the edge of the grid, grab the straight edge, draw in a solid line that goes through all of those. And then for my second one, what is my y-intercept going to be there, Austin? -2 again. And what is my slope this time, Emily? For the second one, I've already graphed the first one. So 1/3, so up and down 1 and over 3, all the way to the edges of the graph. And draw in another solid line. Okay, I'd like everybody now to point for the top line Y is greater than or equal to minus x minus 2. Do I think I need to shade above or below? Point which way? For this top one. The y's are greater than the line, so we think above. And what about the second one? Below. So my first one was the one with the negative slope, so I think I'm looking at above that line. And I think I am looking at below my other line. So those two lines divide the coordinate plane into 4 parts, right? And I need to figure out which part or parts I need to color in. So this part over here is above the first line. Is it also below the second one? So I better not shade there. What about here? So I think this is where I need to shade. Before I color it in, let's pick a test point that is in that section. And again, I can pick any point that is in here. I cannot pick something like 3, -1 because it is on one of the lines. So maybe I want to pick something with an x that's going to be nice for the second one, a multiple of 3. So I could do 3, -2. I could do 4, 5, 6, -1, 6, -2, 6, negative something else. What do you want to pick? Cooper, you want to give us a point to try? Nope. The x has to be positive if it's over here. 3, -2. It's in the region we think, so let's give that a try. We write down that our test point is 3, -2. Put the -2 in for the y. The opposite of 3 minus 2 is -2 bigger than -5? Is -2 bigger than -5? Yep, so that one works. Let's check the other one. We've got to check both now, not just one. Put a -2 in for the y. Is that less than or equal to 1/3 times 3 and then minus 2? 1 minus 2 is -1. Is -2 smaller than -1? Is -2 farther that way? Farther to the left than -1? So -2 is smaller than -1. That works. So this is our region. And you don't need to take time to shade it in real carefully, especially on a test. You've got other problems to go on and do before the bell rings. But do it neatly enough from one line to the other that it's very clear what section you're shading. Questions? Okay, one last one. If those were equal signs in there, could you tell me anything about those two lines before we even start to graph them? Because those equations look an awful lot alike. Leah, what are you thinking? Looks to me like they're going to be parallel. What are both slopes? I'm seeing some people with fingers up. So the slope for both of them is 1. They just have different y-intercepts. So the top one, -3 for the y-intercept and a slope of +1. So do my dots all the way to the edges of the graph. For that top one, solid or dotted line, everybody? Dotted, so let me get my dotted line drawn in there. And then for the second one, y-intercept of +3, again with a slope of +1. Is this one solid or dotted, everybody? Solid, so let me change that to a solid line. And we'll draw that in. Now we have to figure out, do we shade above both of them? So this part up here. Do we shade the part that's between, that's below the solid and above the dotted? Or do we shade this part down here that is below both of them? So for the top line, above or below, everybody? Point. Above or below? So above for that one. What about this one? Below. So we think above the dotted, below the solid. Anybody want to suggest a really great test point? Yo-yo? I love 0, 0. So before I fill that in, I'm going to check if my y's are 0 and my x's are 0. Is 0 bigger than -3? Yep. 0 for the y, 0 for the x. Is 0 less than or equal to +3? Yes. So we do indeed want to shade everything in between. Questions from anyone? Then we will work on homework.